Now we've seen the power of visuals in math, we have one more idea to think about in this lesson: the importance of looking for big ideas in maths.
We saw in the PISA data that the successful students were those who didn't try to remember. They were people who thought, what is the big idea? And other questions like, what do I need to know and what do I know now?
You may get lots of examples to work on in math class, but examples are only ever given to illustrate something general, which we can think of as the big idea. So often math problems will look like this. You'll be told something like circumference is the perimeter of a circle, the distance around the circle. Diameter is the distance of a straight line segment that passes through the center of the circle and the endpoints that lie on the circle. And then you may be given, again, the formula c equals pi times diameter, and then told, well, if we take pi as 3.14, can you find c when d equals 20 inches, find c when d equals 12 centimeters, find c when d equals 2 miles. You can work on questions like that, substituting in numbers, but miss the big idea that all circles have a really exciting link, a really cool relationship, whether it's a teeny circle, a big circle, or a huge circle, or a sphere. No matter what size the circle or sphere, that relationship always gives you pi. There's something really cool about circles and spheres. So first, a couple of bit of terminology. The circumference of the circle or the sphere is the distance all the way around it, as you can see here. The diameter is the straight line segment that passes through the center of the circle and the endpoints that lie on the circle. So that's what the diameter looks like. And here's the cool thing. In every circle and every sphere, the circumference is always a little bit more than 3 times the diameter. And that's true in all sorts of spheres and circles, whether it's a soccer ball, the world, whether it's a flat circle. In every single circle or sphere in the world, that's true. So you may know that circumference is sometimes expressed as diameter times pi, and you may have learned that pi is a really long number like this. But pi is much more than an interesting, never-ending number, because whatever the size of your circle or sphere, when you take the circumference and then you divide that by the diameter, you always get 3 and a little bit, and that's the number pi. So there are 3 and a little bit of them, and that same number again is pi. So that cool relationship exists in every sphere or circle in the world, whether it's a basketball or even just a little gumball. Every time the diameter wraps around the circle 3.14 times.
Students are asked to do problems like that not to practice division or multiplication or substituting d into an equation, but to see a general idea. The radius and circumference of circles are always linked to one number called pi.
I want to show you another example of what I mean by focusing on the big idea. And I'm going to show you an example from fractions. Many people don't understand fractions. They've not been taught them well, and they go through many years of learning fractions without understanding them. Even if you're in 10th or 12th grade or an adult, I think it will be useful to look at this fraction example with us. So you may have been taught rules in fractions.
To divide fractions, you must multiply the first fraction by the reciprocal of the second fraction.
To multiply fractions, you can multiply the numerators and the denominators.
So to add fractions with the same denominator, you can add the numerators, but not the denominators.
These are rules that are very easy to confuse and get wrong. It is very common for students to be taught fraction rules over and over again, and think that learning fractions is all about remembering rules.
But it's not!
To learn fractions well and be able to use them, it's all about learning a few big ideas. If you can learn the big ideas and hold on to them, you'll find fractions really clear and easy to use. The first big idea in fractions is that a fraction is a relationship. No, not that kind of relationship. It really doesn't matter how big the numerator is or how big the denominator is. It matters how big they are in relation to each other.